Welcome to the Decode Podcast. This is the podcast where we talk all things headless WordPress and modern web development. And we're back in your ears this week for another fun-filled episode. This is an important one. This episode is on a topic that's really critical for getting good performance on the web and ultimately delivering a really nice user experience to your website visitors. So make sure you stick around. I'm Kellen Mace, and I'm joined today, as always, by my co-host, Will Johnston. How you doing, Will?
Doing fine.
Let's talk Core Web Vitals, shall we? So that's the subject. That's the topic on the docket today. You might have heard this term if you're in the web development space. This is a term popularized by Google. It's their term for measuring overall performance on the web. So in the past, you might remember other terms like Google used to allow you to run audits from your browser's developer tools where they would measure things like time to first byte and then first meaningful paint and things like that. But over time, they've changed some of those metrics, and now they've come up with what they think are a new and better metric for web performance. And it centers around three things they call the core web vitals.
So something I'll bring up before that. So maybe this is my personal opinion, or it's clearly my personal opinion, but my personal preference. When I think of core web vitals, a small piece of me like rolls my eyes, and it's like, hey, core web vitals, just another marketing term that I don't have to care about. But if that is you, I would really encourage you to look deeply. And I'm sure, most developers who are writing these sites that really depend on ranking high on Google or other search engines do pay particular attention to Core Web Vitals. But the metrics behind Core Web Vitals are very important, and it's not marketing, right? There is a lot of very useful information about how to provide not only an experience that will get you ranked higher on search engines, but also just a better experience for the end user. So it's a really interesting subject if you're interested in optimizing web performance. And I feel like for years since Core Web Vitals came out, the web has just been getting so much better from an end user perspective. And I really do think some of these metrics that people pay particular attention to are the reason for that.
Yeah. Marketing buzzwords notwithstanding, I appreciate what the intent is anyway behind Core Web Vitals, particularly how nowadays they're more focused on the end user experience. In the past, like I mentioned, some of the metrics that were measured when you ran an audit, like from your browser's dev tools, as I mentioned, were things like time to first byte and first meaningful paint and so on. Some of those all of those affect the user in some ways, whether indirectly or directly. However, a website, in that day and age, when those were the metrics we were using, a website could load like lightning quick, but then have a lot of jank. So ads would pop in and images would pop in, and the content on the page would like shift around, and provide a really bad user experience. But it would score well in the dev tools, and Google would give it preferential treatment in its search rankings and so on. So I can appreciate some of the metrics that we'll get into in a minute here that say like those things aren't okay anymore on the web. We need the page to be delivered and for the content not to jump around and be disorienting to the user. So things like that I can appreciate.
Yeah, I think in general you want to work within the bounds of the system, and you need to strike a balance between what is good from a user experience perspective and what is good to rank on Google. And it seems like those are kind of converging, but still that's a decision that you need to make as a developer or a business owner or whatever.
Yeah. So let's dig more into the motivations, right? Because as a developer, if you're listening to this podcast, you may ask the question, why should I care about this? Sure, optimizing performance is always a good thing, but is it really going to affect the bottom line at my company or some some of the things that we're trying to achieve. And I think for me, the three big ones are: number one, user experience. As I mentioned, if your page has a very quick initial load, but then it's janky, content is jumping around as things are, lazy loaded in or async loaded or whatever, that's going to disorient users and kind of turn them off from using your site. Second one is more conversions. So if your site, the goal of it is to have like some kind of lead capture to get people interested in your product and have them sign up for your email list, or maybe it's to make sales, an e-commerce site, that kind of thing. You just get more of them if you score very highly on Core Web Vitals. And that leads into the reason for that is the third one on our list here is that is better SEO, right? Which isn't a shock since Google is the ones kind of promoting this term, this Core Web Vitals term, and encouraging people to strive to hit high marks on these. It's because it benefits them, of course, right, in their search engine. So if you play by their rules and you try to optimize your site to score well in these Core Web Vitals, Google in turn will rate your site more highly. Your page rank will ultimately be higher as a result of that. So let's talk about what are the metrics. So if you read the docs that Google has, like there are many metrics that you could use to measure website performance, but only three of them they call the Core Web Vitals. So that's what our episode kind of centers around. And
yeah, so there will be a link in the description, but if you just go to web.dev/vitals, you'll see a write-up from Google about the different metrics, what each Core Web Vital is. We'll go into it now, but you can go to that site and follow along.
Yep, you get the whole story. Yeah, so the three metrics, then to name them off, the first one is largest contentful paint. And that one is a measure of loading performance. More specifically, it measures the render time of the largest image or the largest block of text. It measures when that is actually visible within the user's browser relative to when the page started loading.
Yeah, and this is an important distinction here. It measures the largest block. I mean, it's images, text. I think there's even videos are involved there. But whatever the largest piece of content is on your site, and when we mean text block, we're talking about like paragraphs. The largest content piece on your site, it measures how long it takes for that to load. I think 2.5 seconds is the target time right now. Obviously, those change year over year based on how the web evolves. But you need to focus on, hey, what is the largest piece of content on every page, and optimize for loading that piece of content as quickly as possible.
Mm-hmm.
That can really hurt if you have large images or large background videos or things like that. So that's something to keep in mind.
Mm-hmm. Yeah, and that's what the user would care about, right? When can I actually see the text or see the image and then start, reading through it or viewing it or whatever that may be. So it's definitely central to UX. The next one on the list is first input delay. And this is a measure of interactivity. More specifically, it measures the time from when a user first interacts with the page. So this is if they click a link or tap on a button or something like that, to the time when the browser is actually able to begin processing those event handlers, tied to that particular event. And I think this one wasn't as much of an issue in the earlier days of the web, when most of the work was done on the server. When the server was the HTML document was rendered on the server and then delivered to the user. It's like as soon as it was visible on the page, then there wasn't much to do after that. Like clicking any links, they were ready to go pretty much instantaneously. And there's very little JavaScript and event handlers going on. But as the web has evolved and gotten more complex, and we have JavaScript frameworks that do add lots of event listeners and handle lots of events, I think this has become an issue.
Yes. Yeah. And actually, and something to point out there too, Web Vitals, the particular metrics, at least the 2020 metrics that we care about, are very much focused on once the content is downloaded. From that point on, the metrics are measured. But there is still the time, the response time from your server. So time to first byte, those kinds of metrics are still very important. So we don't want to forget about all those things because the only thing that matters is loading. It's just once all of the necessary files are downloaded, that's where these metrics start coming into play. And it's really focused on, like largest contentful paint is a loading based metric. First input delay is like a interactivity based metric.
Yeah, and I would say there are a few things more frustrating as a user, than if you're on a website and you see a button, you click on that button and then 1, 2, and then an interaction happens, right? You would immediately think, man, this site is sluggish and bad, and like, why does everything take so long, right? As opposed to a snappy interaction.
It's something that reminds me of back in the day. I feel like now, most of the front end JavaScript that you write, especially using these modern tools and frameworks, is asynchronous first. Like you'll make a fetch request or something, and that's asynchronous. There's like not a synchronous way to do that. I remember back when I started getting into web development, and at that time there was jQuery was like huge. Everyone was using jQuery for their sites, and you could make jQuery requests, XHR. You can make XHR requests synchronously, like just block everything until this is done. And I remember I had it was silly, right? Silly at the time, but it was difficult to reason about how to properly do asynchronous programming at that point. We didn't have all the features we have today, like, the async keyword or even promises weren't necessarily a thing at that time. So it was all like these nested callbacks. And so, silly of me, I was just like, okay, I have this app. It was like an app where I had a map and I was trying to like put a bunch of pins on a map. And I was getting that data from a REST request. And I was just like, well, I'll just block the loading of everything until that request comes back. So you would start up the application or go to the website, and you would see just like a white page until the request came back. So it's like, and sometimes it would be slow, and I wasn't worried. I quickly corrected that. But yeah, if you're responding to some button event or something and you're doing a lot of complex synchronous processing, that is really going to hurt your score on first input delay. It can also really degrade your user experience. So that's a big one that affects user experience for sure.
Yeah. And the third one, the last one we'll cover in this list is cumulative layout shift, or CLS. And this is a measure of visual stability, according to Google. So this is a measure of the largest burst of layout shift for every unexpected layout shift that occurs during the entire lifespan of a page. And so that last phrase is important. It's not just like on the initial load, it's even throughout the whole lifespan of the page. So this would be that website jank that I had referred to earlier. And there's this, brings to mind this meme I've have seen bouncing around the internet, the last few years. Maybe you've seen it too if you're listening out there. It's kind of humorous. It's like this picture of two buttons. One is like, launch nuclear missiles or something, and the bottom button says do not launch nuclear missiles.
A sweaty guy.
Yeah. So it's it's a web page, right? The page initially loads and both of the buttons are visible, and you see a mouse like come into view and hover over the don't launch nuclear buttons, and the person like clicks it, but the moment they do that, an advertisement pops into view at the top of the page and shifts all the content down. And then so the guy ends up accidentally clicking launch nuclear missiles, and then you see the mouse just like shake back and forth, like, oh no. You can just hear him yelling in your head, like, what did I do? Right. So that's a kind of a humorous example, but that kind of stuff does happen where ads will pop in, content will pop in and shift around. It'll be disorienting for the user.
Yeah, I'd say this is where some of the modern frameworks that take advantage of server-side rendering or static site generation come in handy, because they can ship down basically a full built site so that you have as little layout shift as possible versus if you're client side rendering. Think about if you're trying to render client side and you might ship down and client side only, you might ship down like the header relies on a web request, the main content in the body relies on a different web request, the footer might rely on a different web request, and then maybe you have some sidebars or something. And all of these requests will take a different amount of time. And you don't want to just not render anything until you get the data back, because then your page will just be unusable for, a few seconds maybe. And that can really degrade user performance. And even when it comes to text content, it's even difficult to tell how large it's going to be. So it's not even like you can render some empty div that just doesn't need any content layout shift in the future. So that can be difficult. With image, it's a little bit easier, or images, it's a little bit easier, but still there's a lot to take into account there.
Mm-hmm. Yep. So with all that said, now that we know what the metrics are and why we should care about them, what tools exist out there for us to be able to run an audit on our site? So Will, what's on your list? How do you usually measure this?
It's funny. There are plenty of tools that have been developed over time. I guess my first interaction with Core Web Vitals, I don't know if it was even called Core Web Vitals at the time, but was going to the PageSpeed Insights website and just putting in my URLs and and clicking to check it. And the big thing there, and actually with these other tools too, is like you don't want to just put in your homepage. Like people can go to any page on your site, and every page on your site is unique to search engines and to the user. So every page on your site can have a different score or a different ability to do this. But yeah, I remember going to PageSpeed Insights and loading up my site, and then specifically when single page apps came out, I used PageSpeed Insights to understand like, hey, how does Google see my site? Because I was like, hey, they're using their same crawler, and I don't want it to just look like 5 lines of HTML with one div tag in the body, and that's it. So
empty div.
So I was focused on that a lot.
Yep. Yeah. So since then, things have gotten a bit easier, I think, because they've baked in the Lighthouse audit tool into Chrome and other Chromium-based browsers. So I think that's most commonly, how developers would run these kinds of audits. So it's pretty easy. You just pop open the browser dev tools, you go to the Lighthouse audits tab, and then from there you can choose to run either a desktop or a mobile audit. And the mobile is a bit more stringent. You can dig into Google's documentation to see like what exactly the differences are there, but for mobile, you have to be even more optimized and even more performance to score well there, because these folks, they're unlike a desktop where you have, these days it is becoming less true, but a desktop you typically have more power, more resources, and so on, and usually a stable internet connection. On mobile, there's no guarantee, right? This person, their battery's at 2%. They have this really spotty network connection, right? So if your site isn't like performing very well, they'll have a rough time using it.
Yeah, luckily these tools are first of all, they'll show you both mobile and desktop, but I think most of them show you the mobile score as default, and then you can go to the desktop score because the mobile score is usually lower. And I know in the past I've been looking at scores and it's like, oh, well, I have a 99 on desktop, but a 70 on mobile or something. And that, and they're, mobile phones just render things differently, have different capabilities as compared to like very powerful desktops.
Yeah, so we've mentioned PageSpeed Insights. Will mentioned is still around. You could still use that. The Lighthouse audit, as I mentioned, is probably the most convenient. It's baked right into the browser. And beyond that, it's also included in Google's Search Console. There's also a standalone JavaScript library. It's called Web Vitals that exists. And it just ties into like the browser's own navigator object. And it's just kind of a JavaScript wrapper for running those same web APIs for doing the same audits. So it's kind of fun. You could even leverage that library like in your own code if you wanted to in your own JavaScript code, run an audit and display the score or something. You could with this library. And it also is packaged as a Chrome extension as well. You could install and run. Another cool thing is it's possible to run a Lighthouse audit as part of your continuous integration pipeline. So Will was doing a little research and he found a GitHub action, right, for that?
Yeah, I've never done this, but I did see some people who had some GitHub actions. I'm sure there's something for Circle CI and what is it? Oh my gosh, Jenkins and other continuous integration tools. But I saw a GitHub action for Lighthouse scores, and the developer in me kind of cringed for a second at that, because I was thinking like, hey, there's some product owner somewhere who is saying, if we don't hit these scores, the issue's not done or something. And so there's some developer just sweating trying to get like 1 point in their Lighthouse score somewhere. But it can be a really useful tool. So that's something that I want to look into for sure.
Yeah.
And actually the Web Vitals JavaScript library is new in Core Web Vitals with, I think it's like 8.4 that's coming out. So that might actually add a lot to some of these continuous integration pipelines as well.
Yeah, that's cool. Yeah, I can see that being really beneficial. I've heard of teams having what they refer to as a performance budget. They say like, this page, which it has a lot of media and a lot of interaction, whatever. We know we're not going to get 100% because it has, it has this virtual map where users can pan around. It has to load a lot of resources. So like, due to the nature of the page, maybe we can't get 100, but our performance budget for this page is 85% or whatever they've determined, right? And then as the website, changes and evolves over time, they could do something like this CI pipeline thing where they run an audit and to say whatever changes were made to the page, if we're 85 and below, great, let that go to production, that's fine. Otherwise it would flag somebody. If it's less than that, they'd flag it and say, all right, what's being done? Is this a mission critical feature that's going to push it below our performance budget? And at that point, they could choose to reevaluate it and maybe lower it if it's worth, the feature they're implementing is worth it for end users, or otherwise maybe optimize something and fix it.
The other thing I'll bring up is some of that automation that you could do around Lighthouse scores is actually good for not just ongoing maintenance and stuff, but just lots of people will build a site and then they optimize it when that site is released, and then they don't think about it ever again. And maybe that site had a 99 on day one, and now things have changed in how the metrics are calculated, or some dynamic content has brought down your score a little bit. Maybe somebody uploaded a really large image or a video or whatever.
Right.
So it's good to have some automation around Lighthouse scores, or at least routinely check your Lighthouse scores.
Yep, absolutely. Yeah, so next we'll talk about how to fix these issues. And Core Web Vitals are so all-encompassing. Many of them, like there are lots of different performance gains that you could get, lots of different techniques you could employ to achieve better performance that ultimately result in these metrics going up, yourself getting a higher score. But we've put together a list here we think are some of the most valuable or the most common ones that you get a lot of bang for your buck for, so to speak, if you were to implement these. So the first one we'll dive into is having your scripts, any external scripts that your page may load in, doing that asynchronously. So you can apply either async or defer attributes on scripts to enable this. In the olden days, several years ago, it was common to just like throw your scripts, any blocking scripts, you just throw in the footer, so your user, because it would execute things and render things top down, that, well, at least the user has the above the fold content. They can see that at least. And if my page gets blocked in the footer while it's loading some external script, no big deal because they're not there yet, right? But these days, thankfully, we have even more elegant ways of doing that, where you can have your script tags even at the top of the page, like in the head, where they probably should belong, But if you tack on either async or defer attributes, that tells the browser, don't wait for this. Don't make it render blocking. Instead, continue processing the page. And you can do this, when there are CPU cycles available to get it.
Yeah, those attributes are really nice for me, because I know that I always want to go and look in the head to find your CSS links or your script links or something. And if they're like embedded in the bottom of the body somewhere, it can be difficult to find them.
Mm-hmm. Absolutely. Yep. So, and you'll see this if you run a Lighthouse audit. A very common thing to see there is remove render blocking scripts or render blocking styles, and that's what it's referring to. I mean, something is preventing the browser from rendering the rest of the page. So you need to address that somehow. Next one we had on here is bundle size, and this one, Will, is your suggestion we include. Many of these are provided by modern frameworks. So what do they give us?
Yeah. So, bundle size, when we say bundle size, we mean not just your JS bundle, but any HTML or CSS. Now, some of the modern frameworks, that's all those things are kind of in one. But there are frameworks that still have separate HTML from your JavaScript, from your CSS. I think now it's still pretty common to see CSS separate from your JavaScript, but generally you want to reduce your bundle size. And given that you have multiple, your site is going to have multiple pages, maybe not every page needs all of the JavaScript that you have for your whole site. So modern frameworks and build tools like Webpack or different build tools can take advantage of two main things. There's code splitting, and that is understanding what JavaScript is needed for each page. This frameworks like Next.js and Gatsby, those are very good at allowing you to do code splitting because you are building the individual pages. That does not mean it's impossible to do that without those tools, but they make it easier. The other thing is tree shaking. So say you're using a library like Lodash or even Material UI, right? A large component library. You want to be sure that you only your final bundle size only includes the code that you're using out of those libraries. And tree shaking has come a long way, and now is pretty much built into the modern build stack that people use. But that is a big deal. You want to make sure that just because you're including one function from a dependency doesn't mean you have to include the entire dependency. And then, and in the future, frameworks are coming out with a lot of different concepts like the React. We've talked about this plenty of times on this podcast up to this point, but React server components, just being able to define, hey, this JavaScript is only used on the server versus the front end, will be a huge thing going forward with respect to bundle size. But all of that is, you can think you gain two advantages out of making a smaller bundle. One is it is quicker to get the data from your server to your front end. And actually, I guess three advantages: your users do not have to download as much data. But the second one is a browser can process your content faster if it's smaller. So it's pretty, pretty much a no-brainer there. But you want to be taking advantage of all the latest and greatest tools for optimizing your bundle size.
Yeah, and I would say, for me, this is one of the big differentiators between traditional monolithic WordPress and choosing to decouple your front end from your back end and going for a headless WordPress approach. I've for years and years, I had written traditional monolithic WordPress sites, and just know from being in that world that there's this separation between the theme API, where you're doing all of your templating, where that lives, and then where your styles live. Typically, you have like Sass partials in one part of the code base, and then separate from that, you might have JavaScript. And what's typically done is a build tool is used to concatenate and minify a single CSS file that provides the styles for your whole site, and likewise a single JavaScript file that provides the interactivity for your whole site. And you ship both of those down, whether or not the user actually needs all of those styles and all of those JS for the current route that they happen to be on. And that's not entirely true. There are ways of breaking it up. If you know for certain that some JavaScript is only needed for a particular page on the site, then certainly you could have your build tool break that out and then enqueue that JavaScript file on only the page that's the page in question. But that kind of splitting out, you have to do manually. You have to do yourself. You have to look at, where is this thing used, what template's being used, where's the JavaScript. Now I'm going to manually tell the build tool to split out this code and only load it on a certain page. So that kind of stuff, that's what you get for free with a lot of these modern frameworks. And the reason for that is they know where everything is being used. So if I'm using some component-based framework, in a component, I'll have the markup that it outputs. I'll have the JavaScript code that provides any interactivity there as well. And then if I have some kind of scoped CSS, so if I'm importing the Sass file right in that same file, or I'm using styled components or emotion, some CSS in JS solution or CSS modules, whatever your choice of styling is, if it's scoped to that component, now all of a sudden my build tool knows exactly which pages that component belongs to. It can trace the whole component tree. So the end result is it can build these very optimized bundles. It knows if somebody hits the /about page, that person needs exactly this JavaScript and exactly these styles for the route that they're on. If they go somewhere else, then more requests would be fired off to get the CSS and JS for the next page that they go to. So some of these criticisms or problems that you'll encounter when you run Lighthouse audits for shipping more CSS than is needed for the current page, or more JS than is needed for the current page, can be alleviated or mitigated in a lot of cases by some modern frameworks.
Yeah, so something specific, or like a concept that some of these modern frameworks like a Tailwind implement is like atomic CSS, or I think it's also called just-in-time CSS. Yep. So for styling, so that lets you, rather than the concept of, I have all this CSS, now let me purge it, and like come up with a list of unused classes that I purge. Just-in-time CSS flips that around and says, I'm going to write my CSS and then actually generate based on, or write my styles and generate based on only the styles that I've written. So it saves a lot of headache there. But the caveat with CSS in general is, if you are using something like a lot of our viewers are building headless WordPress sites, WordPress has dynamic content, and you need to be careful and make sure that you are going to
you're going to ship all of the styles. If you're
using something like, all the styles, you need to be careful if you're using something like a purge CSS.
Yeah, so like Gutenberg content would be a good example, right? You would want to make sure that you're shipping all of the styles necessary to style all possible Gutenberg blocks on every blog post page, for instance. Even though 100% of the styles might not be used on this particular blog post page, that's okay. But because that content can change from page to page, and that you'll have the styles required for a certain page, you can kind of prune things down pretty closely, even still. Yeah, so we should mention also, we've done a separate episode on the podcast called Styling on the Modern Web. That was just 2 or 3 episodes ago, I believe. So be sure to check that out if you want more of a deep dive into like how to optimize some of the styles. Next up, we have images, and there's a lot there. Images are huge on the web, of course, and can be optimized like in a number of ways. So one of the ones I want to talk about first is serving responsive images. So WordPress just added support maybe 5 years ago or so, 4 or 5 years ago, for responsive images using the source set attribute, SRC SEC. It used to be if you included like an inline image in your WordPress blog post, there would just be an image tag with, that pointed to a single JPEG or a single ping or whatever else. And every user who viewed that image, their browser would just obey that image tag and get the image from the source, URL that was specified there. But with the advent of mobile devices in particular, that's very inefficient because if a user is on a smartphone with a very small screen, and your source attribute for your image is pointing to this image that's huge, it's meant for 40-inch, desktop monitors, there's a lot of inefficiency there, right? That person doesn't need an image that big for their device. So the web, has evolved since then, and now there's a source set attribute on image tags where you can specify different versions of that image depending on the widths of the device that the user is on. So WordPress core, provides that the source set attribute now. And as our listeners likely know, WordPress also, whenever you add images to the media library, it will generate different sizes of that image for you that can be served up for different purposes, the thumbnail, small, medium, large, and so on. So it's possible to leverage all that functionality in the headless decoupled world as well. So you can query for your image and get not only its source, but all of its source set data, all of its alternate sizes and the URLs to the other sizes. And then in your front end application, you can build up that image tag, providing all of those other sizes as well. So that results in very quick loads for images, particularly on mobile, as I mentioned, where you only need a small image in many cases. Next on the list is lazy loading. So, rather than loading images initially when the page first loads, deferring that and doing it later. And it's even come natively to some browsers at this point. So like, Will, have you ever used the native laser loading?
I have, yeah, I've used it a little bit. I think that the crazy thing to me is now like browsers are supporting this out of the box, which is really amazing. But one thing I think about with lazy loading is it's not like a set it and forget it kind of thing, because when it comes to optimizing your website, you might think, oh, I'll just load all of my images lazy and then it'll be fine. But that might degrade your user experience, because your user wants to see, if the image is part of the interactivity of your website, your user wants to see that quickly. It doesn't want to, the image to get deprioritized in the queue of assets that are loading. So that especially comes into play with largest contentful paint. If you have a huge image that you want to try to optimize by saying load this, lazy load this, and then it gets pushed down to the bottom of the queue, it has to wait for all those assets to load and then your image loads. And meanwhile, search engines like Google or your rank on Lighthouse or your score on Lighthouse can get degraded because it'll take that much longer for the largest contentful paint to happen.
Yeah, so good tip there. So this might be valuable, if you had a slider of like, you might also like products or something that was like further down the page or something like that. That's not the largest part of the page that the user is interested in seeing. It's more of a supplementary data, right? That's further down the page, and you could likely lazy load those images without incurring any issues. In fact, it would help performance because you wouldn't have to load them when the page first loads.
Yeah, so I think generally you would want to avoid certainly any above the fold content. You want to think twice before. I'm not saying you shouldn't lazy load images on above the fold content, but you might want to think twice before you do that. And also any large images on your page, you might want to see if you should lazy load them or not, and how it affects your largest contentful paint score.
Yeah. So for years, it's been possible to lazy load images manually with some JavaScript. So you'd have to use intersection observer to figure out where the user had navigated on your site, or what part of the viewport was in view. And then when an image was about to come into view, then you'd have some JavaScript that would fetch the image and then insert it. But now Chrome's, they're the first ones to implement a native lazy loading, as we said. So it's possible now for images and even other elements actually like iframes you can do this with as well. You can specify a loading equals lazy attribute,
Yep.
and that'll tell the browser to do that for you. So no more custom JavaScript. It'll just figure out, what images are currently in view and what images are about to be in view if the user's scrolling, and it will, fire out that request to fetch the image for you now. As of the day of this recording, that's not in all browsers though. Like Safari doesn't still have support, and I believe it's like partially implemented in Firefox.
Yep.
Right now. Next up on the list, we had having placeholder images for some elements on the page, and then replacing those with the image, or maybe you have a low res version of an image, you swap out for a high res version.
Yeah, so something to be really cognizant of with images and even in videos, stuff that can take a little bit of time to load because maybe you have larger files or something like that. That can affect your cumulative layout shift significantly as well. So, so you want to, if you are loading a lot of images, you want to load not only, you can load placeholder images that might be low res so they can load faster and then you can backfill them with the images. But you also want to be sure that you loading your images does not cause a jerky loading layout shift in your site. So with that, you want to know ahead of time what the size of the image is, aspect ratio and length and width, or width and height of your image on your page, and make sure you have a placeholder for that amount of space on your page so you don't get that layout shift.
Yep. Yeah, and this is another one where it's been possible to do this for years. I think it was popularized, I think, by Facebook. Was one of the first big sites out there, I think, to serve the low res placeholder images. They would then get swapped out for the high res ones, and then a lot of other folks on the web followed suit. And I think Gatsby is one of the frameworks that really popularized this and made it very easy. They came out with an image component and just said, if you use their image component and point it to where your image lived, it would take care of running it through its Sharp library that it has to generate a low res image of that and save that with your project. And it would inline that. I think it's like a base64 encoded image that's just right in the body of your HTML. So it doesn't even take a network request. Actually, it's just like, an inline image right in your content. And then they would, Gatsby would take care of swapping that out for the actual high res image that also lives in your project elsewhere. But it's just so, so darn easy to do that. I think a lot of Gatsby projects, benefited from having that make the easy thing, or make the right thing the easy thing kind of method that Gatsby brought with their image component. And now Next.js has followed suit as well. They have a image component themselves that does similar things. External services, let's talk about those. So Cloudinary is the one that comes to mind for me as probably the most popular one out there, but they're an option as well for optimizing images on your site. Cloudinary does some very cool things, like it can generate different image sizes on the fly. So even if you've uploaded a certain size to Cloudinary, if it sees a request has come in, and in the request it's asking for a different size of that image, it will in milliseconds it'll generate that new size you're requesting, and then serve that up. So in your web app, it makes it very easy to have multiple sizes without manually generating those yourself.
Yeah, Cloudflare can also do this, and there are a few other tools that can help optimize images. And actually, Next can plug into those. So if you're using Next image components, you don't have to rely on Next itself to do the image optimization. You can point it to Cloudinary or Cloudflare or these other tools to say, hey, that's where my image optimization is happening. So that helps a lot if you are trying to serve files over a CDN and you want to integrate with that, like a Cloudflare.
Nice. Yeah. So in addition to the automatic resizing and serving sizes, Cloudinary, from what I've heard, does an excellent job with optimizing images as well. So they'll strip out any metadata, any extraneous things that might, bloat the size of images. They'll strip those out to make them very small, which is helpful for performance. And not only that, but they'll serve the images that are appropriate for the user's browser. So what that means is if your original image was a JPEG, let's say, they'll generate a WebP version of that perhaps, or a new format on the scene is AVIF. It's gaining support and is becoming more well supported on the web. So Cloudinary, when a request comes in, they can actually take a look at the user agent and know, oh, this user is on this type of browser. It supports WebP. I'm going to serve up that version rather than my JPEG version because I know it's 60% reduction in the size or whatever else. So yeah, get several gains if you go for a service like that.
Yeah. So along those lines, you mentioned different formats like AVIF and WebP. There are multiple different formats of images. The standard ones that people use in browsers are like SVGs, PNGs, JPEGs, and then WebP is on top of a JPEG or a PNG, and then there's the new AVIF format. Something I'll say is that you might, I'm not an image expert. I'm not a graphic designer. Like I don't follow a lot of that stuff, but I will say that don't just think that, hey, you can create a WebP on your own and it's always going to be smaller than your underlying PNG or JPEG. Sure. That's not always the case. It depends on how it's configured. Same thing goes with JPEGs versus PNGs. A JPEG is not always going to be a smaller version of the same PNG. Mm. So you have to optimize for the image that you're showing. And then also with SVGs, don't just go and turn everything into an SVG. SVGs are particularly good at certain kinds of vector graphics and not necessarily pictures.
Right. Yep, absolutely. So that was a lot on images, and it's a whole world, of how to optimize images, but I think we hit some of the highlights there. Next, we want to talk about dynamic imports in JavaScript. This would be another option. We talked about code splitting, tree shaking, things like that to limit the amount of JavaScript that gets served on page load. But another option that you would have is just to strip things out, so that they don't appear in that bundle on the initial load, but rather they're imported dynamically. So that could be, if the user interacts with the page in some way and hits a button that says like, this says that they want a map to pop up or something like that. What you could do is when they click that button, you could just dynamically import the JavaScript necessary to power that map, and now all of a sudden they have it, but you didn't have to pay that cost on the initial page load, because maybe from your research you figured out 90+% of users don't click that button and don't need the JavaScript for that map. But for those other 10% who may click the button, no problem. We'll fetch that JavaScript needed for that particular resource or particular feature on the fly, when it's needed. So you can just Google that, dynamic imports. There are different ways of doing that depending on your build tools and frameworks and so on, but it can be really helpful. How about prefetching? Have you done much of this, Will, with links?
Yes. So a long time ago, like 5 years ago or so, I built my own prefetching tool for a framework that I was using, and it was a little bit cumbersome. Say now some of these modern frameworks like Next.js and Gatsby, they make prefetching a lot nicer. So what we mean by prefetching is if you load a page and then your mouse kind of hovers near a link, then you might want to go and prefetch all the resources you need to get to that link. So you can keep the user client side and immediately just pop that new page in there without having any delay at all. And Next and Gatsby and some of, many of the front end frameworks are really good at doing that for you now, and even allowing you to configure which URLs should be prefetched.
Yep. Yeah, and it's not free, right? This is another one where you need to be careful. You could just say like, well, if it's faster, I would just prefetch every single link that's everywhere on
Yeah.
my site, right? But if you have 100 links, then their browser is going to be the main thread of the browser is going to be very busy grabbing all of those, prefetching all of those pages. So I would say, just be mindful of like when you use this. It is a huge performance booster, and maybe if when users come to your site, if 80-90% of them all go to the shop page, since it's an e-commerce site, prefetching that, if someone's on your homepage, prefetching the shop page so that when they most likely do click that link, they get a nice immediate cut over to shop. I think
Yep.
something like that would be appropriate, but not doing it for,
Yeah.
like I said, every link under the sun.
Yeah, you want to be careful because say you have a sidebar, maybe you're doing a documentation page or something. You have a sidebar that has a tree of all of the pages that you can go visit on your site. You might not want to prefetch every single one of those pages when a user comes to one of them, right? So,
Yep.
so yeah, you need a good balance. Definitely prefetching things that are within the main content that somebody might be viewing on your site. That's more where you might want to do some prefetching.
Yeah. Yeah. So you can prefetch at different times. So like what I was referring to with the shop link example, that would be like on page load. You can just say when the
Yep.
page is done and things are idle, at that point, prefetch the shop page because they'll probably go there. And when they do, we'll have a nice, instantaneous cut over there. I will describe another option though, and that is like you can do it on hover. I've seen
Yep.
some statistics that say users who are using a mouse or a trackpad, they will actually hover over a link something like 300 or 400 milliseconds before they, before the on-click event happens. So what you could do is, as Will described, you could just listen for, when that hover happens, start prefetching the page then, so that when they actually do click, maybe you're halfway through, the request. So it just feels like a quicker one. And that would be an example
Yeah.
of perceived performance, right? It may be that your server isn't responding quicker than it was yesterday, right? But because you have this on hover effect that just starts fetching the pages a little bit quicker, it just feels a bit more snappy to the user.
Yeah. The when it comes to Core Web Vitals, some of the prefetching stuff doesn't really apply to some of these Core Web Vital scores. In fact, sometimes it can cause them to go down. Not particularly the Core Web Vitals, but things like server response time can go down because if your prefetch requests end up in in the queue above other assets on your page, you want to avoid those kinds of things. So the hover effect works, or saying, hey, load this on some delay. So after my content has actually loaded, that's when I want to prefetch. All those things are important to take into account. But yeah, just simply prefetching assets and HTML and maybe some scripts. That's not necessarily going to bump up your Core Web Vitals score or your Lighthouse score. It's something that you want to do for user experience and for general, usability of your site and perceived performance, but it doesn't necessarily at
Sure.
this time, at the time of this recording, does not necessarily affect your Lighthouse score.
Mm-hmm. And for folks listening who, maybe you maintain or work on some traditional monolithic WordPress sites, there's a great plugin called Flying Pages that you can turn on, and it allows you to have control over what gets prefetched and adds a nice prefetching effects for nice transitions between traditional monolithic WordPress sites, or otherwise many of the frameworks we've talked about in a headless environment would, as Will said, allow you to easily add this as well. So prefetching, that's where you grab the HTML document of that next page that you're interested in loading ahead of time. And there's such a thing as preloading as well. So you can do a similar thing, but just for different types of assets. So if there's like a font or an audio file or video file, that you're going to need very soon for based on something the user's about to do. If you know ahead of time, you're going to do that, there's an option there as well. You could preload those so that they're available. Another one I want to plug real quick, just because the library I like a lot, I think it's cool, is this library by Paul Irish. It's called Light YouTube Embed. This one I think is really cool because it's nearly indistinguishable from a traditional embedded YouTube video, but it just loads the YouTube iframe on demand is what it does. So So the traditional YouTube embed, what it does is it has an iframe where it loads, the actual video into your page, and you pay a performance cost for that. And all the user sees is the image of the video with a play icon in the middle. So this library I use on some projects as a replacement for that, because the user on the page sees the same thing. They see the video thumbnail with a play icon in the middle. It looks exactly the same, but the actual iframe, the video hasn't been loaded yet. It's only when they click somewhere on it, it on the fly, will at that point fetch the iframe and then swap out the image with this iframe to play the actual video. So libraries like that are cool, just for getting some quick wins when you have embedded assets and want to speed things up. Another service I've heard of folks getting some gains from, getting some mileage out of, is polyfill.io. I think this is less relevant these days, where we have these evergreen browsers that are releasing updates constantly, and the amount of polyfills that you have to include in your projects, I think, is getting less and less compared to a few years ago.
Something I will say is that, Safari is kind of the one nowadays that's a little bit behind the times. So,
True.
So polyfills are still needed, but yeah, it feels like with the, end of support for IE 11, and now we're all on evergreen browsers, it's becoming less and less necessary to focus on polyfills, and that's for JavaScript and CSS. Polyfills are a little bit less necessary now.
Yeah. So this service, polyfill.io, is a cool one you might want to look at. I believe it's an open source service that you can use. And what it does is it detects what browser the user is running based on their user agent, and that would serve to that person only the polyfills that they need. So if the person is running like the latest and greatest Google Chrome, for example, they'll get next to no polyfills, since that browser would be very up to date. Otherwise, if they're running a version of Samsung browser that they haven't updated in 2 years or whatever else, it may, the service may ship down the polyfills that user would need. So the cool thing there is you don't have to include them in your code, in your bundle. You don't have to serve these to all users, because some of them actually don't need them. So the service allows you to only serve polyfills to users who are going to need them, which is cool. All right. Next, I want to talk about content visibility. This is one that only came across my radar within the last year, I think. I think it's a relatively new addition to browsers. And also, we should mention for browser support, I don't think it's supported in all browsers yet either. But what this is it's a content visibility attribute that you can apply to some kind of a container, like a div on your page. And it's a way of telling the browser not to calculate the layout of anything inside of this container ahead of time. And it can result in better performance when you do that. So again, like we've said several times, this one you want to be careful with. In CSS, it's possible to do lots of things on the web, right? If I have a div and something is inside of that, it may not look like it's inside of that, right? I may be using position absolute or position fixed and putting it somewhere else on the page. So browsers have to do a lot of fancy footwork to figure out where things are actually positioned, because it may not be how they're represented in the HTML. And also with the advent of CSS Grid, that's another one, right? You can make it so that the item that's fifth down on the list actually looks like it's the first, right? Because in CSS, you've positioned it at the top. So because of those things, what the browser typically does is it will figure out all of the layout for the entire page, and then it's actually able to start painting the page, and that's what the user actually sees. So with this content visibility utility here, it's possible to tell the browser, I know that the content inside of this particular div, none of it is going to be displayed fixed or absolute or somewhere outside of this. I know all of it is going to be encapsulated within this, and I'm just going to save you the work of calculating the layout ahead of time. So don't worry about doing it now. You can do this when the user's about to scroll it into view. You can defer that work until later. And that, depending on your site and what content is there, you can get some significant performance gains out of that.
Yeah, I mean, this is it. there's a concept for this on iOS and I believe on Android too that apps take advantage of it. And actually, it's inherently built into the language that iOS uses to build your applications. So that's it's nice that that's kind of being brought to the web. And it actually makes me think a lot about how people have for a few years done like virtualization. So like infinite scrolling on lists and things like that, where content visibility is a little bit different, but it basically takes that concept of virtualization and applies it to, something you inform the browser of, right? So
Mm,
where in virtualization, you don't even put the HTML on the screen until the right moment. Content visibility allows you to put the HTML there, but inform the browser, hey, don't worry about this until, it's necessary.
yep. Yeah, and I believe I misspoke. I said it was an attribute. It's actually a CSS properties that you would apply
Yeah.
to these elements. Yeah, so check that out. We'll include the link in the show notes if you want to see what that looks like and why you might want to use it. The video is kind of funny. Jake Archibald from Google, who does the video, he actually takes like the official HTML specification, which is this like large document on the web, and he says, what could we do? How could we affect the performance if we applied, content visibility none to that, or content visibility hidden, I believe it is, to that container? What would that do to performance? And then runs an audit and figures out like, oh, it's 500 times faster or whatever, because the browser no longer has to calculate the layout for all of these elements on the page. So that's a cool one you have at your disposal as well. Next, let's talk about tooling. Will mentioned a good point that we want to bring up on this podcast, and that is like Next.js, which is, of course, a very popular React-based meta framework, introduced some linting rules, right? And they're specific to performance on your site.
Yeah, so I'd say Next.js, I think it was 11, but either 10 or 11 came out with this concept of lint rules that they publish that are specifically targeted at Core Web Vitals, as well as just general, Next usage and following best practices for Next usage. This is really awesome, and if you're building on a Next project, you should totally be taking advantage of this. I'd say right now they're last I checked, there were only a handful of rules, and they basically do what a lot of people are already doing when they're building these sites. However, that does show a commitment to Core Web Vitals, and it's something that will only get better over time. So it's something that would be good to start using now.
Yeah. So another optimization that I don't see people in practice using, but I just think is cool. So I'm going to throw it out there anyways. And it could be helpful if you have some really computationally heavy stuff going on your site. That is offloading work from the main thread to web workers. So in the browser, we have the main thread, and that's what's responsible for all things related to layout in the browser and rendering things to the screen. That's what the main thread handles. Beyond that, though, it also responds to events that happen, and you don't want to tie up the main thread with too much work, because then you get kind of a janky experience and lag. The first input delay and so on would be affected if you tie up the main thread with too much work. So it's possible to offload that work to something else. You can have another thread handle that. So that would be called a web worker. So I believe the dev advocate is his title at Google, Surma. He created this really neat library called Comlink, and it just puts like a really nice wrapper around the web workers API in the browser and makes it promise-based. So what you can do in your JavaScript code is, if you have some computationally heavy thing to do, you can call Comlink and say, here's my task, let me know when it's done. And it'll return a promise, and then you can respond to whenever the promise is resolved. Then you'll know that work is done, and you'll get the data that it sent back and so on. So that could be cool if you have any computationally heavy things going on. I would say anything that has to do with rendering content to the page, don't do this. Like, leave that in the main thread. That's what it's for. But other things like number crunching kind of work, you could offload that to another thread.
Yeah, you can't do any UI. The main thread in JavaScript is the UI thread, so you can't do anything with the UI in your worker threads. And I mean, anyone who has done any thread-based programming, it operates pretty similarly. So you have a message that you can send back from your web worker to get it back to your main thread. But yeah, if you have any, the worker thread is for IO, not necessarily DOM manipulation and things.
Right. Yeah. Yeah. And I guess another thing you could do even these days is WASM. You could do WebAssembly stuff if your app has some computationally heavy stuff to do. You could offload that to something more performant like C++ or Rust or something, and then get the response. So that'd be yet another option beyond web workers even.
Yeah, I'd
Next,
say if you're for most of the sites that are concerned about Core Web Vitals and things, you might not go down that path.
Yeah.
That would be like the last form of optimization.
Yep.
If you've tried every other thing, because there are so many other tools available to you now to make some of this stuff very easy. And WASM is still not very easy. Same with web workers.
Absolutely. Yeah. Yeah. So probably not advantageous to the average web developer, but still cool to know about, I think. Like one impressive case study is Figma. My understanding is like it's an in-browser, image editing software that a lot of folks know and love. And it's supposed to have a very good user experience. I don't have a ton of experience using the web app, but it's supposed to have very good experience. And my understanding is all of the image modification, work that's done, that's all offloaded to WebAssembly. So that code is run in something like Rust, to do all the data intensive modifications to images. And then when it's done, that WebAssembly will respond, and then JavaScript, they render the result to the screen. So for projects like that, then it might actually be worth it to consider offloading this work, so that your main thread isn't attempting to render gigantic images and do computationally heavy things. So with that, we've gone through what we wanted to in terms of things to look at, kind of tactics you can take to increase your core web vitals and get really performant sites, really good scores. And we should have a few closing things here. One is a case study. So like, Will, do you want to talk for a second about Android Authority?
Yeah, so WP Engine recently released the Atlas platform, and part of that is it's partly a node hosting platform. And Android Authority is one of the early adopters of this platform. And Android Authority had a traditional WordPress site, and they have gone to headless, and they're on the Atlas platform. And they noticed, obviously once they went headless, they did some optimizing and things, but they noticed that when they just simply moving from traditional WordPress to headless WordPress gave them a huge jump in light speed, in their light speed score and their Core Web Vitals in general, because they were able to take advantage of some of these modern frameworks that have a lot of this baked in. And to me, that speaks to how there are optimizations you can make in WordPress, and WordPress has been developed over years. There's always a plugin that you can install that can help you optimize your performance in some way, shape, or form. And WordPress is focused on that. And even take it the other way, I mean, Google is focused on working with WordPress to make sure that WordPress understands what the future of Core Web Vitals is. However, some of these modern frameworks are very easy, like quick to adapt to some of these upcoming things in Lighthouse scores, and they're really moving the needle in terms of user experience and performance on websites. So taking advantage of these modern tools is something that just without any additional optimization on your own today, you can very easily increase your Lighthouse score.
Nice. And lastly, we want to talk about an upcoming event that WP Engine has, and we're doing in conjunction with Google. So what's that event all about?
Yeah, so the event is just going to be a deep dive into Core Web Vitals. WP Engine is in partnership with Google, so we're going to be talking about that a lot, and that event will happen after the recording of this podcast, but once it's released, it'll be happening soon.
Very nice. So stay tuned for that if you're listening to this podcast episode before that event happens. Otherwise, I just want to thank you for listening. Thanks for tuning in to the podcast and hearing us drone on about all things performance and Core Web Vitals for this episode. Will, thanks for being on with me. And listeners, we will catch you in the next episode.